Hi guys, Miss O'Connell here. So today we're going to do a quick review of acceleration and how to find average acceleration in addition to two concept-based questions. So our equation for average acceleration, we have that average acceleration is the rate of change of velocity in respect to time. So what that means is that the final minus the initial velocity value divided by the time will give us our acceleration. As we spoke about in our previous classes, objects can accelerate in three ways. Those three ways are related to the components of your car. So you can hit the gas, meaning you can speed up. You can hit the brakes, meaning you can slow down. Or you can change direction by pulling your car in reverse or turning the wheel. Okay, so if our direction changes, we are also accelerating. Acceleration, we know, has the units of meters per second per second. So in concept example number 6, we're given a description of motion for a horse. A horse gallops with a constant acceleration of 3 meters per second per second. Which statement below is true? A, the horse's velocity does not change. Okay, so we know that can't be true because change in velocity over change in time is acceleration. So if our velocity doesn't change, we're not accelerating. According to the problem, the horse accelerates at 3 meters per second per second. So that eliminates answer choice A. The horse moves 3 meters every second. So if we consider what those units would look like, right? If we move 3 meters every 1 second, that is 3 meters per second. So that would be the same as answer choice A. This would give us a constant speed or a constant velocity. So B cannot be our answer choice. Okay, constant velocity means that we are not accelerating. And C, the horse's velocity increases 3 meters every second. So we do know that acceleration is change in velocity. So if velocity is increasing, technically that means acceleration. But take a look at these units here. Right, 3 minutes every second, 3 meters every 1 second is really 3 meters per second. So although the wording says the velocity increases, the units are not dimensionally consistent. In order to receive an acceleration rate, we have to have meters per second per second. So that seconds there would need to be squared. In answer choice D, we have the similar wording here. The horse's velocity increases 3 meters per second every second. Okay, so that means that every second, the velocity increases by 3 meters per second. That would give us 3 meters per second squared. So technically, the right description of motion to match that acceleration rate would be answer choice D. Okay, we have to dimensionally get meters per second squared in order to show acceleration. Okay, concept question number 7. So number 7, we're given 4 different carts, cart A, B, C, and D. And on these carts, we're shown velocity and acceleration vectors. The direction that vector points tells us whether it's positive or negative. Okay, so in A, our acceleration points to the right, so acceleration would be positive. In A, our velocity points to the right, so our velocity would be positive. In B, our acceleration vector is pointing to the left, so acceleration is negative. Our velocity is pointing to the right still, so it will be a positive value. In C, our acceleration is to the right, so that's going to be a big positive value. But our velocity is pointing to the left, it's moving to the left, so velocity is negative. For for cart number D, cart letter D, acceleration is negative and velocity is negative because both of those vectors point to the left. Okay, so now that we have the signs for the acceleration and the velocity down pat, let's take a look at the two components to this question. So in part A, we're asked, in which scenario does the car's speed increase? So how do we know if an object's speed is increasing? What do we need to look at? To determine if speed is increasing, we have to look at the signs. We have to compare signs for the velocity and the acceleration. We talked about this in our last class, and we practice it on the concept builders. We have to compare the signs for velocity and acceleration. If the signs are the same signs means that the object will speed up. If the signs are opposite, that means that the object is going to slow down. Okay, so if we want to figure out when the object speeds up, we're looking for the situation in which the signs for velocity and acceleration are the same. So let's head to A. So for cart A, acceleration is positive and velocity is positive. So this object is going to speed up. In B, acceleration is negative and velocity is positive. So these signs are opposite. Opposite signs mean that the object is slowing down. C, again, we have opposite signs. So cart C is slowing down. Cart D, acceleration and velocity are both negative. So the object is going to speed up. So when does the speed increase? Speed up is cart A and cart D because the signs are the same. We're going to see slow down or a decrease in our velocity. When our signs are opposite, which is answer choice C and answer choice B. So carts B and C are going to slow down. In part B, we're asked to figure out in which scenario does the car have a negative acceleration rate. To figure out when acceleration is negative, we're looking at the direction of that acceleration vector. So whenever that vector is pointing to the left, our acceleration is negative. So in cart B and cart D, we have negative acceleration because our vectors are pointing to the left for acceleration. Okay, so cart A is speeding up, technically in the positive direction because velocity is positive. Car B is slowing down, still in the positive direction because velocity is positive. Cart C is slowing down in the negative direction because velocity is negative. And cart D is speeding up just in the negative direction because our velocity is negative. Okay. So last one, let's just take a look at one more example in which we're finding average acceleration, but the direction of the velocity is changing. So for your average acceleration questions, which you did a whole bunch of them for homework, I highly suggest that you draw a diagram. When you draw a diagram, you are less likely to make mistakes. So I'm going to draw the situation to help you to interpret and picture what's going on. Label what you're given and what you're asked to find. Using your givens and what you're asked to find, then identify which equation you need to use to solve that question. So let's take a look at number 19. So Jim and Cindy decide to go on a ferry ride together as friends. The ferry makes a short run between two docks, one in New Jersey and one in New York. As the ferry approaches New York, traveling in the positive x direction, so that tells us the speed is positive, its speed is 7.4 meters per second. In this case, because we're moving in one direction, the speed is the velocity. Okay, so our diagram here, we are starting in New Jersey. Here we are in New Jersey, and we are, or technically Jim and Cindy are on a ferry. And they're traveling to New York. Okay, New York, according to the diagram, or our problem, is in the positive x direction. So to the right of where we started. And this is where the dock is. Here's our dock in New York. So its speed, initial velocity, v initial, is a positive, because we're moving along the positive x-axis, 7.4 meters per second. In part A, it says, if the ferry slows to a stop in 12.3 seconds, what is its average velocity? So if it slows to a stop, our final velocity, v final, is 0. This will take the ferry 12.3 seconds to change its velocity to 0. We're looking for A average, or average acceleration. So for part A, our average acceleration, we're going to take final minus initial velocity and divide by time. We're going to plug in what we know and leave what we don't know as a variable. So I don't know the acceleration rate. I'm going to leave it as a variable. My final velocity should be 0. So 0 minus my initial, which is 7.4. All divided by 12.3 seconds. When we plug that into our calculator, we're going to get 0.6. That's a negative 0.6. And what are the units? Meters per second squared. Meters per second gives us meters per second squared. So we have negative 0.6 meters per second squared. Okay, so how do we know that this acceleration is correct? Why should the acceleration be negative? Why should the acceleration be negative? Well, as the ferry slows from some positive velocity to 0, right? It's slowing down. We know that the signs for velocity and acceleration should be opposites. So initial velocity is positive, so that means acceleration should be negative if the object is slowing down. So we know that we did the algebra correctly because the signs make sense with the description of motion. Okay, so for part B, pause the video and give this one a try on your own. Unpause the video when you have an answer and you're ready to go. Okay, so for part B, we're starting in New York and we're heading back to New Jersey. So this time, the dock is all the way here in Jersey, and our ferry is going to start in New York, and it's going to move in the negative direction. So our initial velocity, because we are moving backwards, our initial velocity is negative. We're moving in the negative direction. So V initial should be negative 7.3 meters per second. The ferry will slow to a stop, so final velocity when it reaches Jersey will be 0. And it's going to take 13, so a little bit longer this time, 13.1 seconds to accelerate to rest. We're looking for the average acceleration. So we should have acceleration is equal to final minus initial velocity over the time. Our final velocity here again is 0. The initial velocity is negative 7.3. So I have 0 minus 7.3 meters per second, all divided by 13.1 seconds. So 0 minus a negative, we get a positive value. 7.3 divided by 13.1, we get positive 0.5. And our units are meters per second squared. So I'm going to ask you guys again, how do you know that that acceleration is correct? Based on the sign. How do you know that that acceleration is correct? Well, just like the first situation, we're slowing down. It slows. So our velocity and acceleration vectors should have opposite signs. Our initial velocity was negative, so that means that our acceleration vector should have a positive value or a positive direction. We have to have opposite signs in order for the object to slow down. Okay, and last part C. If the ferry took longer to come to a stop, would that mean that it has more or less acceleration? So if it takes more time to decrease the velocity, what does that mean about acceleration? If you take a look at the equation here, right? Or even if you compare answers A to answer B, if our denominator is larger, our acceleration is going to be less, okay? Just like pizza, right? If you have to split a piece of pizza or a pizza pie with more people, you get less pizza. Same thing with acceleration, okay? If the denominator is larger, we're going to have less acceleration. So if it takes longer for your speed to decrease, you have less acceleration. To figure out numerically, if you compare A to B, that negative sign in front of the vector is just the direction, right? That depicts the direction. Positive and negative depicts the direction. So if you're comparing accelerations, you're comparing the value, the number. So this took less time to come to rest, so acceleration is larger. If it took more time to come to rest, like in answer choice B, we have a smaller acceleration rate. So if it takes more time to decrease your velocity, you have less acceleration. So please make sure, just a reminder, to upload a picture of these notes to Google Classroom when you have them completed. Email me with any questions. And thanks for watching.